So let's start with a very brief review. Chapter 8. We're off to a good start here. Chapter 8 is on quadrilaterals, but you guys said quad means what? Four. Chapter 8 is all about quadrilaterals. Chapter 8. Excuse me. Excuse me again. The math in Chapter 8 is fairly simple. The first section is probably the hardest in terms of using the math. The focus of Chapter 8 is there are a lot of properties. So it means there's a lot of items that we're going to have to memorize and practice. In years past, I will tell you this has been a challenging section. You cannot afford to get behind, okay? It's going to be very hard to catch up. So you just got to stay with me and make sure you stay on task, okay? So that's your warning. Let's start with a quick review. Section 8.1. So we're going to start today. We'll finish it tomorrow. Our goal is to find the measure of interior and exterior angles of polygons. So we remember polygons from, I forget which chapter that was, chapter 1, I believe. Polygons are any shape that's straight lines, and it has to be closed. So it has to form a closed shape. A circle, is a circle a polygon? No, because it has to have points, right? It cannot be curved, straight lines. So a triangle, is a triangle a polygon? No. Why not? Is a triangle a polygon? Doesn't need 5. It can be any number of sides. Has to be closed. Is the triangle closed? Yeah. Are they all straight lines? Yeah. So let me ask again. Is a triangle polygon? Yeah. Is it square? Yeah. Is it a rectangle? Yeah. Is it a pentagon? Yeah. Good. All right. Quick review for our names. So what do we call something with 4? Quadrilateral. Now, we did this a long time ago, but what does lateral mean? What does lateral mean? If you have a lateral in football, you throw the ball to the side. So quadrilateral means literally 4 sides. Okay? What do we call a 5-sided figure? What is it, Gustavo? Pentagon, just like DC. Luis, do you know what 6-sided is? Mario. Anybody remember what 6-sided is? Ryan. What is it? Hexagon. Not quite. It's hexagon with an X. Close. Hexagon. Taz, do you know 7? Anybody know 7? Not quite? It depends. It's a Greek root versus a Latin root. We use hexagon. 7 is heptagon. Everybody knows the next one. What's 8? Octagon. Give me an example of an 8-sided figure. Stop sign. What's that called if all the sides are equal and all the angles are equal? There's a special name. Equilateral and equiangular. If it's both of those, we call it something special. No. If it's both equilateral and equiangular, we call it regular. Regular. So the stop sign is regular. Okay? A 9-sided figure, everybody know 9? What is it? What's it? Very close. It's a nonagon. 10? Decagon. Easy way to remember 10. What is a decade? 10 years. 10 years. So a 10-sided figure is a decagon. Now 27, we have a little skip here. Is there actually something? No, well, there might be, but not that I know of. So once it gets over 10, we switch And we'll just call this a 27-gon. So you can answer me the next one. If it has 68 sides, what do we call it? 68 gon. So what if it had n sides? An n-gon. So n stands for the number of sides here. So it could be, n is a variable. So it could be 18, it could be 23, it could be whatever it wants to be, okay? So whenever it has n sides, you just call it whatever the number is, gon. Just like we did for 2768. Does that make sense? All right. We need to talk about diagonals, right? Diagonals. So a diagonal is a line segment diagonal is a line segment that joins or connects. Diagonal is a line segment that joins or connects two non-consecutive vertices. Non-consecutive vertices. Now those are some big words, so let's see if we can break this down a little bit. Do we remember what consecutive means? Okay. Close. Consecutive. So when I say that 3, 4, 5, 6, 7 are consecutive numbers, what does that mean? They're in order, or they're in a row, or they're next to each other. So non-consecutive means that they are not next to. So they're not next to each other. And the vertices are just, vertice is the plural of vertex, and the vertex are just my points. Okay? So I want you to draw two pentagons. Two pentagons. How many sides for a pentagon? 5. We're going to draw the diagonals. So for the first one, I'm going to draw all diagonals. So I'm going to draw all the possible diagonals. So we need to draw the line segments that are going to connect two non-consecutive points, right? So not next to each other. So we start at any point in our pentagon. Let's start here on the left side. So I'm going to start here. I need to draw line segments to the other ones that aren't next to it. So if I go to my left, is that next to it? Yes. It's the point right next door, right? So we can't draw that one. So let's skip that one. Is this one right next to it? So can I draw that line? So there's one. Does that make sense? What about this one in the bottom right? Could I draw a line between my original and this one? Sure. And now I'm back to my bottom left. Is this one next to it now? Yes. So can I draw a line there? No. So really it's only drawing lines across your shape to the opposite corners. Does that make sense? But I asked for all of them, so we need to go to the next point. Eventually. So go to your next point. Can I draw it to this one? No. Can I draw it to this one? Draw a dotted line. Can I draw it to this one? Yeah. Okay, you guys can complete it now, I hope? So connect any points across the triangle. So start looking for any points across the triangle. There's only one more. Good. So if you draw the pentagon, you get a nice, pretty star in the middle. Right? So this is all the diagonals. All of them, okay? Any questions with that? Cool? Leslie? You okay? Now I want to draw the diagonals for one point. So the diagonals for one vertex. In this case, I'm going to choose the top vertex. How many diagonals can I draw from that? Where are they? Tell me when to stop. Can I draw it to here?
No.
What about here?
Yes.
Okay. There's one. Can I draw it to here?
Yes.
And then here?
No.
No. So if I do it just from one vertex, it's going to look like that. Does everyone see the difference between all of them and then just from one point? Okay. Any questions on this? So diagonal is pretty easy. The next thing we need to talk about is interior angles. This should not be hard because we did it before. The interior angles are the angles inside the shape. So inside the polygon. So as we go around, all you have to do is highlight them. So interior angles be here, here, here. It's just every angle as we walk around the shape. And it's always on the inside. So if you talk about an interior decorator, to decorate the inside of houses, right? So interior means inside. Easy? And this is what we talked about this with triangles, remember? How many degrees did all triangles add up to? 180. Okay? Didn't matter the shape. Any triangle, okay? So you can draw any shape here. You can draw a triangle, square, it doesn't matter. The interior angles are just the angles inside. Okay? The next page, we're going to do something different for this. So the Polygon interior angle theorem is incredibly important, which is why I did it so big. But we're going to do this. We're going to try to figure this out on our own. So we're going to stop right here and start doing that little activity here.